All right, hello everyone. Hope you're enjoying your Black Friday and getting some good deals. But today we're going to solve LeetCode Hard 127 word ladder. A transformation sequence from begin word to end word using a dictionary word list in a sequence of words from begin word, SI, S2 to SK, where SK is the end word, such that every adjacent pair of words differs by a single letter. Every SI in the word is in the word list, and note that begin word does not need to be in the word list. SK equals end word. Given two words, begin word and end word, in a dictionary, return the number of words in the shortest transformation sequence from begin word to end word, or 0 if no such sequence exists. So let's quickly look at the first example here. We see that we have the begin word of hit and the end word of cog. Hit differs by one letter to the word hot. If you just change the middle letter to O instead of an I, we can transform it into hot, so therefore it has a valid transformation. From hot, we can transform the first letter to make it dot. From dot, we can transform the last letter to a G and make it dog. And lastly, all we need to do is change the D to a C and have cog. And cog is our end word, therefore we reach the transformation. And hit transformed 1, 2, 3, 4, 5 times, and that's why the answer is 5. In the second example here, we have begin word hit is the same and end word cog, but the word list is a bit different. In this transformation, we can actually check, and we see word list doesn't even have the word cog in it. So that means that we can never transform to the end word cog because it's not even in the word list, which is our accepted words we can transform to. Therefore, we return 0. All right. So in a question like this, first, I like to really think about the approach. So firstly, we have to know, how can we tell if a word differs to another word by one character? I actually wrote it down here, but I'm going to go over like the brute force solution first, and we're going to explain this hash map here. So a naive solution would be to get the word, then iterate through every word in the word list and see, hey, does this word differ by one of this one, and go on and on and on for every single word. But that would be very computationally expensive and be very inefficient. A more efficient way would be to pre-process all the patterns. Then we could just do a O of 1 lookup in this hash map. So I'm going to quickly explain why this hash map works. So let's say we have the word hot and we want to find, hey, what are all the words we can transform to that differs by one word in hot? All we have to do is look up the pre-processed pattern. So if we have the word hot, H-O-T, if we want to replace the first letter, we have a blank O-T, and we check, is that pattern inside of our hash map? We see blank OT is there, so that means we could transform to hot or dot. Of course, we won't transfer it to hot because we've already at that character or at that word, so we would pick dot. And you can quickly pause and look at this, but that's essentially how this works, and that allows us to transform words and look up an O of 1. Next, I want to cover the algorithm we'll be using. We're using a breadth first search, and that's a graph traversal algorithm. And you might say, how is this a graph problem? Well, think about it. We're actually traveling from begin word to end word. So we could think about each word as a node in a graph, and the edge will be the traversal. So let's start off the algorithm. So let's say we start off with the word hit. So we're at hit, H-I-T. And we want to say, all right, what are the available words we could transform to? So first we look at the first pattern. So there'd be blank, I-T. And we check, hey, is that a pattern in our word list? No, there's not, so we won't be using that. Next, we'd have H blank T. We see H blank T, it has one, but it's hot. So we say, all right, we could transform to hot. So hit goes to hot, which is a valid node. And since we've already seen hot, we're gonna X that out because that means we've been there before. Essentially like a scene or a set. So now that we transformed, we're no longer at hit, we're at our current word is now hot, and we do the same exact process. So do we have the first pattern would be blank OT, and we say, hey, is there any words in word list that have blank OT? We see hot and dot. Hot, we've already been there because we're currently there, so we're not going to check that. I'm quickly X that off so it's a good visualization. And the next word is dot. We haven't been to dot, so we're going to transform to that word dot. So we go from hot to dot. And now we're at dot, and we've seen it before, so I'm going to quickly cross that out. And we do the same exact thing again. So first, blank OT. So do we have anything in blank OT? Well, we have hot and dot, but we've used both of those, so we can't do that. We have to look at the next pattern. We have D blank T. D blank T is right here, and we see dot. We've already been there, so we're not going to go there. And the next pattern would be DO blank. All right, perfect. So we're at DO blank, and we see dot, and we actually have been there, so we're not going to use that. But the next word is dog, and we haven't tried that yet, so we're going to transform to the word dog. D-O-G. Perfect. So now we're at dog. I'm going to cross it out because we've seen it before. And now that we're at dog, we check all the patterns. So we say blank OG, because that we want to go in sequential order. First, we're going to move this blank sequence from the first letter in the word, into the end of the word, replacing it a letter. So we could see if it differs by one. So blank OG, and we see dog, which we're already at, so we're not going to go there. Cross that out. And we see cog. Well, cog we haven't been to before, so we're going to transform the cog right here. And we have C-O-G. And we see, hey, the current word that we're at is actually equal to the N word, which is cog. So that means we're actually done. So all we have to do is check how many words have we transformed to so far. 1, 2, 3, 4. All right, so we see that our current word is cog. And we say, hey, how many words have we transformed to from hit? So we have 1, 2, 3, 4, 5, and we return 5. And that would be the answer there. So this breadth first search algorithm, it will find the shortest path first because we're doing a breadth first search, not a depth first search. So we're checking all adjacent pairs first. All right. All right. So I'm going to go into how to code up a solution like this. So first, we know that we're going to have a pattern map, which we illustrated here. And we see that the key is going to be a string of the pattern of the current word. And the value is going to be a list of all the words that we can transform to from that pattern. So what we like to do is start off with, let's say pattern map equals dict. And default dict, all it does is if you don't have a value inside of a key, it will default it to whatever you put in here. In this case, a list or an array, because as you see, the values are always going to be an array. Next, what we want to do is fill up this pattern map. So we're going to say for word in word list, because we want to iterate through every single word. Next, since we know that all the words of this are of the same length, we say for I in range length begin word. And this is actually arbitrary. You could use n word, begin word, because they all have the same length, so it doesn't really matter. But I like to use begin word because that's where we're starting at. And here's where we're going to actually create the pattern. So we're going to say pattern is going to equal the current word we're at, and we're going to say I. We're going to start and end at I, and next we're going to have our wildcard. So in this case, I like to use just an underscore for a blank character. And lastly, we want to have the rest of the word starting at 1 plus wherever I was. So word I plus 1 to the end. So all this does is, let's say we had the word hit. It's going to first store blank OT, then it's going to have H blank T, and then finally HI blank, right? So this is what this does. Each pattern is just going to show me all of the patterns. Since there's 3 letters in the word hit, it's going to have 3 patterns. And now all we want to do is store all the words that match that pattern. So we're going to say pattern map at pattern dot append, because it's a list. And what do we want to append? The word, because this is the word that matches this pattern, right? So now we've essentially created this pattern map here, and this just gives us fast lookup so we can see if a word can transform to another word quickly, right? Nice. So once we did that, now we're going to actually start our breadth first search algorithm. So first we want to create our queue. So queue equals deque, and first we want to start off with begin word, and next we want to have a count. Remember, because we have a count of how many transformations we made, the begin word is the first transformation, so we're going to start that at 1. Next, we want to have a scene because we don't want to go to the same word twice. So it's going to be a set with scene in it. And remember, what do we want to have inside of our set? We want to have begin word because that's where we started. We don't ever want to transform back to begin word. And next, what we want to do is actually create our while loop, because to go and fill things into our queue. So while queue, we're going to say word so the current word that we're at, and count for the number of transformations equals q.pop left. So here, this is essentially where we have the word hit. Now we're popping it off. So now we have hit and 1. And we're going to cycle through all the transformations of this word here, hit, and see, hey, what things can we transform into? So first we're going to say for I in range, length, word, and we're going to do the same exact thing we did up here. We're going to say pattern equals word plus blank. So our wildcard, because remember we have to have the same format we had up here, so it matches the exact pattern, plus word. There we go. Now what we want to do is say we want to cycle through all the words that we could transform into. So if we had the word hit and we get the pattern, let's say hit, it has blank OT. That means we'd be here, and we first want to iterate through all of these words that we can transform into, right? So for, I like to call it neighbor, because these are words we could transform to in pattern map at pattern. We say if neighbor in scene, because we don't want to go back to it. If neighbor not in scene, so I'm going to say if neighbor not in scene, which means we haven't seen this word, it's a brand new word. We want to say scene dot add neighbor, because we want to add that in there. So we could say we've seen this word before, right? And next we want to say, hey, well, what if the neighbor actually equals the N word? That means we're done. So if nay equals N word, then return count plus 1, because that just means we have to transform to that last word and we're done because we found the N word. But if not, then we want to add it to our queue. So we're going to say q dot append, and first we're going to append the neighbor that we haven't been to and count plus 1, right? So I'll cycle through all of the adjacent words. And lastly, what we have to do is, let's say we run through this whole entire queue and we don't find our answer, then what we're going to do is return 0, because that means there is no possible transformation to get to n-word, so return 0. And let's actually try this out. Let's see what happens. Well, it's always one typo. I put seam instead of scene. Let's try that one last time. There we go. We solved the question, and it's actually pretty efficient. So I hope you learned something new in this breadth first search algorithm and how to cycle through these words and look at problems and really think about the words as nodes and the connections between the next word as an edge. So hopefully that was really a main point of this video. I really want you guys to understand the thought process behind problems like these. And peace. Comment down below if you have any questions.